Welcome to Research Methods in Psychology. Over the course of this semester, we'll learn about the scientific approach to studying human and animal behavior. Why does psychology use the scientific method? In a nutshell, it just works better than other ways of understanding the world. Science is responsible for eradicating certain diseases, for developing modern medicine, and for creating modern inventions that improve the quality of our lives. In this lecture, we'll explore the characteristics that make psychology a science. What does it mean to say that psychology is a science? The scientific method represents a field of study, such as psychology or chemistry, but it also represents a body of knowledge and a process for acquiring that knowledge. But how does the scientific method differ from other ways of knowing? Some examples of non-scientific approaches to understanding behavior include using common sense or your personal intuition or just plain casual observation. Psychology is unique in comparison to other sciences because we study something that feels very familiar to us, behavior. I doubt anyone would suggest that gastroenterology or subatomic physics were just common sense, the way you often hear people say, psychology is just common sense. However, common sense is just a form of guessing, and guesses about behavior are often wrong when a closer look is taken. As an example, imagine that you come home to find that your dog has pooped in your living room. What do? Many of my students have suggested rubbing the dog's nose in it to teach the dog a lesson. But does this common sense approach really work? Actually, it doesn't. The science suggests that preventing accidents by restricting the dog's access to an area and rewarding proper elimination in the yard work much better. In addition, when you harass your dog by grabbing him or shoving his nose into feces, you're damaging the relationship between yourself and your dog. Another non-scientific approach is pseudoscience. Pseudoscience, which also means false science, looks like science, and it has what Colbert might call a truthiness about it. That is, it feels like it's the truth, so it must be. Take the anti-vaccination movement, or the belief that, in particular, vaccines cause autism. This is an example of pseudoscience. The widespread fear that vaccines increase the risk of autism stems from one paper that has since been completely discredited due to serious procedural errors, undisclosed financial conflicts of interest, and ethical violations. The researcher that published this article has since lost his medical license, and the paper was retracted from the journal in which it was published. However, all of the anti-vaxxers do not mention these aspects of the study. Another way in which people can learn about the world in a non-scientific way is to rely on authority. These are so-called experts, and oftentimes they're self-anointed ones. They can include religious figures, the internet, the news media, celebrities, government. We just can't accept their claims based on faith. They must be backed up with scientific data. As an example, there's a popular dog trainer on television who really has absolutely no knowledge of canine behavior or anything about training or adjusting the behavior in a dog. However, because he's on TV and has a show and an audience, people assume that he is an authority. So what makes the scientific approach different from these other approaches? For one thing, it's empirical. That is, it's data-driven. If I tell you that I have a product that virtually erases wrinkles, you just rub it into your skin and all of your wrinkles vanish, what do you say? You say, show me the evidence. I want to know what percentage of people saw a difference in their skin. How big was the difference? How long does it last? How much does it cost? I want to see the data surrounding your claim. Until we see the data, I'm going to be skeptical. I need the evidence that something works before I accept your claim. A scientific theory is also falsifiable. What that means is that inherent in every well-written scientific theory is the ability to disprove it. Now, why would a scientist create a theory that allows other people to disprove it? Because science is self-correcting, and we improve theories over time. So we do this by making scientific claims that are incredibly specific and detailed, unlike non-scientific claims which are often vague or untestable. For instance, consider Freud's theory of penis envy, the idea that little girls unconsciously wish they had a penis just like boys do. How would you even test this? Do you ask girls? Most girls that I've asked in a casual poll in class have denied wishing that they had a penis. One crazy study at my alma mater even attempted to demonstrate penis envy by doing a little test where they gave kids in their class a survey that they passed out pencils along with. The researcher recorded how many students kept the pencils. Lo and behold, more females kept them. The crazy researchers concluded that demonstrated penis envy in females. What the heck? If you can't have an actual penis, this implies that a pencil is the next best thing. It's completely ridiculous. There's really no way to test whether or not girls have penis envy. So theories like Freud's theory sticks around because you just can't refute it. The other thing that makes science unique is that before any scientific paper gets published, it must be evaluated by other scientists in the field for quality, accuracy, and to check that appropriate methods were used. As little as 1% of scientific papers get published. We publish our papers in specialized journals that are very specific to a particular field. For instance, in graduate school, I relied on journals like the Experimental Analysis of Behavior and Animal Learning and Behavior and Behavioral Neuroscience to look at some of the research that was relevant to what I was doing. What are the goals of science? Science seeks to describe, explain, predict, and control behavior. In particular, with psychologists, we're interested in describing what people or animals do. For instance, I work with a lot of dogs who have bitten someone, very often a child within their own family. A proper description of the problem might take into account general data, like what types of people, men, women, children, are most frequently bitten. It turns out that little boys are bitten more frequently than any other individual. We'd also want to look at the specific circumstances and describe those in detail. What happened immediately before Spot bit Johnny? Johnny was up in Spot's face, teasing him. Then we try to explain the behavior. That is, we want to say, why did the behavior occur? If Johnny was teasing Spot and didn't stop when Spot growled, he missed that cue, the dog's built-in warning system that tells you to back off. If little Johnny, because say he's only 4 years old, didn't realize what the growl meant, and he kept teasing Spot, then obviously the dog's next effort is going to be stronger than the growl, and he's going to bite. So we understand the behavior once we've explained it, and this allows us to predict when the behavior will occur. Dogs might bite their owners, for instance, when they ignore their growls in other situations, such as if the dog had a tasty bone and the owner went to take it away and the dog growls. We might predict that if the owner continues to go after the dog's bone, that they're likely to get a bite. Once we're able to explain and predict the behavior, we can control it. We can influence it. We can say, how do we influence this behavior? This often means preventing unwanted behaviors or changing the environment to elicit different behaviors. Whenever a dog has something you don't want him to have, the best thing to do is trade him for something better. Another area that we might want to look at before we delve into specific methods for doing scientific research is just the basic distinction between basic and applied research. I've done both. Basic research really is just scientists exercising their curiosity, asking fundamental questions, looking into theoretical issues. They're just excited about why the world works the way it does. They're not necessarily interested in changing the world or making any improvements or doing anything to help anybody. They're just kind of big kids asking questions about the universe. So for instance, a physiological psychologist might specialize in asking questions like, what are the effects of prolonged stress on the body's immune system? They're not necessarily interested in finding out how to help people better manage stress. They just want to know what's going on inside of the body when stress occurs. And in particular, what is the immune system doing? A developmental psychologist might ask, how do child rearing practices affect adult personality? They're not necessarily going to do parenting workshops. They're just looking at the relationships between how you raised your kid and how they ended up as an adult. Applied researchers take what was learned by the basic researchers and try to find the practical implications or the ability to solve problems using this information. So in applied research, you're actually putting the information to good use. So counseling psychologists might say, once we understand what leads to loneliness and sadness in college students, how can we reduce that on college and university campuses? Now it's time for a pop quiz. Ask yourself, are these basic or applied research questions? 1. How can we help adolescents deal with difficulties associated with being homosexual? 2. How do people understand and produce language? 3. What is the relationship between the physical brightness of a light and how that light is perceived? And 4, how can a computer be designed to prevent fatigue and eye strain?